Hello and welcome to the videos on cryptography. In this video series, you can find videos on introduction to cryptography to many advanced topics such as zero knowledge proofs, key maintenance, DES, etc. Throughout these videos, I will try to give real life analogies to understand the topic in an easy and better way. So to start with, what is cryptography? As Bruce Steiner explains, imagine that I have a letter and if I keep it somewhere in Sunnyvale and ask you to read it, it's not actually security but it's obscurity. On the other hand, if I take a letter, lock it in a safe and give you the safe along with the design specifications of the safe and 100 other safes with their combinations so that you and the world's best safekeepers can study the mechanism, and still you or those safekeepers cannot open the safe and cannot read the letter. Now this is actual cryptography. The best way to understand cryptography is to take some real life examples. So let's start with a story. Alice wants to say hello to her friend Bob, but she doesn't want anyone else in between to know what she is actually talking. Now Eve is sitting in between Alice and Bob, and who can capture the communication packets going back and forth between Alice and Bob. Now in this example, Alice is a sender of the message, Bob is receiver of the message, Eve is the eavesdropper who can actually capture the packet, and the hello message was the plain text message which needs to be transmitted to the receiver. Now let's see how Alice will exactly transmit the message. Instead of sending plain text hello, she will encrypt that message with some shared secret which will be known only to Alice and Bob. Now the function of encryption block is to transform the message in such a way so that no one other than Bob will be able to decrypt it without the knowledge of the shared key. Now this scrambled message is called the ciphertext message. At the receiver's end, with the help of this shared secret, Bob will decrypt the message to again generate the plain text hello message. Now this whole technique of encryption and decryption is called cryptography. Or more formally, the art of keeping message secure is cryptography, and it's practiced by cryptographers. Cryptanalysis, on the other hand, is an art of or science of breaking the cryptographic keys. The branch of mathematics which does cryptography as well as cryptanalysis is called cryptology, and the practitioners are called cryptologists. The whole cryptography can be mathematically represented in the following way. M is a plain text message, E is some encryption function which will be applied over M to get the C, that is ciphertext message, after encryption. So when encryption function is applied on the message M, the C, that is the ciphertext message, is generated. Now D is the decryption function which is a counterpart of the encryption function. So D of C will be again the plain text message M, that is the decryption of the encrypted message C, ciphertext, will be again the plain text message M. Or in other words, D of E of M is again the plain text message M. Now a natural question, why to have cryptography? Or in other words, what is expected from a good cryptographic algorithm? Now the first important thing that any cryptographic algorithm should give is the confidentiality. Intruder should not be able to read the message while the message is in transit. Second thing is the authenticity of the message, or the origin authenticity. The cryptography should provide some way to check if the message has been actually originated from the person with whom I am talking with. So if an intruder is sending the message on behalf of the source, the cryptography should be clearly able to distinguish between these two messages. The next is very important thing, that is integrity. No one in between sender and receiver should be able to tamper the message, or simply if tampering is happening, the receiver should be able to find out clearly that the message is not original but it is being tampered in between. And the last important thing is non-repudiation. There should be some way to prove that the message is actually sent by the sender and the sender should not be able to falsely deny the sending of the message. These are the 4 important things any cryptographic algorithm must provide. One possible way of security can be by obscurity, like keep the algorithm itself safeguarded so that only a closed group of people knows how exactly encryption is happening. Actually, it is a very bad idea. If some member of this closed group leaves the group, then every other member has to adopt to a new algorithm, and there is no way one can find out whether this new algorithm is really secured or not, because it is not tried and tested by all the world's best crypto analysts. So the best algorithms are always open algorithms, and algorithm should be open, and all the secret sauce or all the secret should lie in the key. So the key based algorithm working will be something like encryption with the key will happen as EK of M equal to C, or the ciphertext will be the encryption with the key K. Similarly, decryption will be DK of C, ciphertext message equal to the original message M, or the overall function will be DK of EK of M equal to the original message M. Now it is not compulsory that the encryption key must be equal to decryption key. It is possible that the encryption and decryption keys are different, and in that case the functions will be like EK1 of M equal to C is the encryption function to generate the ciphertext. Decryption function will be DK2 of C equal to M, that is the K2 key will be applied to decryption algorithm. So overall function will be DK2 of EK1 of M equal to original message M. Simple. There are 2 types of key based algorithms, symmetric key algorithms and public key algorithms. The requirement in symmetric key algorithm is like same key can be used for encryption as well as decryption, or given the encryption key one should be easily able to derive the decryption key. Public key algorithms on the other hand is a separate branch of cryptography where no shared secret is present, and still there is very good strong algorithms or strong security can be achieved with public key algorithms. Talk more about symmetric key algorithms, either same or derivable key is used for encryption as well as decryption. Now on this key, sender and receiver both have to agree. Whole security of this algorithm is in keys. If any key is exposed, the communication is no more secure and sender and receiver have to change the key. Now there are 2 types of ciphers available, stream ciphers and block ciphers. I will be creating separate videos to explain these stream ciphers and block ciphers. I will be also adding more detailed videos on different cryptographic algorithms and different types of cryptographies on securitytube.net. You also feel free to upload your own videos on network security or application security or any other security concepts on securitytube.net. Thank you.